Hey everybody. Okay, we are now moving on to day 2 of graphing quadratic functions. Remember the term we use for the shape made by a quadratic function when we graph it is called a parabola, right? And so we are going to continue to practice graphing these, which or not necessarily graphing these, but graphing certain features of these, and then determining what they are in relation to the graph and how that can help us in certain applications, okay? So we are going to find and interpret the maximum or minimum value of a quadratic function. So hopefully you kind of remember, have a little bit of memory about maximum and minimum values, right? So maximum and minimum values are like when you have the highest or the lowest point of, of whatever you are graphing, right? And you can have like relative or local maxima or minima, or you can have just a general maximum or minimum of a graph. And for parabolas, they have a general one. So you have either one or the other, and you're only going to have one, all right? Because a parabola basically makes that big kind of curve, right? So so if you think about this, right? The maximum and the minimum, and think about what that's going to be. So I want you to think about like the shape of what a parabola looks like, right? And we're going to go over this in a second, but think about the shape of it, right? So the maximum or minimum value, in this case, it's going to be the top of this thing, so right there. And then think about what is that called, right? What do we call that point that is the top of it? Well, I'll give you a hint. It's the same thing where the axis of symmetry goes through it, right? And that is called the vertex. Right? And so basically what we're going to be finding today is the vertex of these things. And we are going to look at how is that helpful to us. And we're also going to look at something that's going to lead into later talking about a certain value of transformations of quadratic equations, all right? So we're going to talk about maximum and minimums. We're going to talk about interpreting those, and then you will have an opportunity to practice. So for the remainder of the video, I'm just going to work on this next slide, and then we're going to stop, and we will break it up so the video isn't like 9 years long. All right, so basically the whole idea, because we talked about this, right? So in this case, right, this is your vertex. In this case, this is your vertex, right? So these are your vertices. That's plural of vertex. You don't say vertexes, you say vertices. It's one of those things. I don't know why, but that's what they do. And in this case on the left, right, so in this case, right, this is going to be a minimum because it is the lowest point of the graph. There is nothing that is going to be higher than this, right? This is the lowest the graph will ever get because the end behavior of this thing is going up to positive infinity that way. And then over here, it's also going up to positive infinity. So we need to recognize that, well, if they're both exhibiting end behavior on the right and the left side, so this is as x approaches positive infinity. If you guys remember your end behavior notation, this is as x approaches negative infinity, right? And then this would be f of x, right? Approaches that, f of x approaches this. So if you have a case like this, right, and it's symmetrical like this, it can only be a parabola, right? And that's basically what we're working on. I mean, it could be, I suppose it could be something else, but for quadratics, obviously, that's how parabolas work, right? So hopefully that kind of makes sense. That was a bit of a rambling mess, but it's just, you can see it, look at it. This is the bottom of the valley. Think about it however you want. This is a minimum. Now, in this one over here, right, you have this point right here, and this is the maximum, right? Because there's nothing that is going to go higher than this on this graph at all. This one is going to continue to go towards negative infinity for your y. Same over here, okay? So that's why we call them maximum and minimum, right? And then we have to recognize now, so the important part of this and what you really need to pay attention to with this is that the y coordinate of the vertex is your maximum or minimum value of the quadratic function. So we're not looking for the axis of symmetry, right? In this case, your axis of symmetry is this line right here, right? That goes through the vertex, and it's right here. and they were very nice, and they made them the y-axis in both of these. So we're not really interested in that other than the fact that it helps us to get to the vertex. And then once we find the vertex, that value is my height. Well, your height is always your y value because y represents your up and down measurement on the graph, right? It tells you where you're at in relation to the origin as far as height goes, as far as your vertical distance. So if you can remember that, and just remember basically find your vertex, and then you are going to use the y-coordinate from your vertex is going to represent your minimum value or your maximum value. So to recap, you are finding your y-coordinate of your vertex. All right? That's what you want to find. That will tell you what your max or minimum is. Okay? So that's what we're looking for, and that's what we're going to talk about in the next two videos, and that's what we're going to find, and we'll interpret that. All right? So thanks for listening. A bit crazy, but hopefully you get the idea. All right? So we'll see you in the next one.